Question 3, we're given this diagram of a pendulum of mass. It doesn't say mass m, but that's what it's supposed to say. And the pendulum, which is 1 meter long, makes an angle 60 with the vertical. Just going to bring this line across here. And we will be able to get this height then above this bottom line, which is what we're going to call our h is equal to 0 line. So if I want x here, and I label the triangle using trig from junior cert, you have a and h. When we have h, we're looking for a, so cos of 60, we use cos 60 x over 1. So x is equal to 1 cos 60, which is just the cos of 60, which is 0.5. So just get rid of this x, change it to 0.5. So this one has to be 0.5 because it's the same length of pendulum. So let's look at, we're looking for the speed at the lowest point here. So at position 2, we're going to have a v. So we have position 1 and position 2. So let's look at PE plus KE for position 1. So PE is mgh. So we have m g by 0.5 or a half, plus kinetic energy a half, m by v squared, which is 0. No speed up here. So position 2, so that's just going to give me 0.5 mg. So position 2, I'm going to have mg by h. Position 2, h is 0. And the speed a half, m by v squared, and the v is what we're looking for. So 0.5 mg is equal to, this is 0. This one was 0, so it's equal to this one, 0.5 mv squared. So we can cancel 0.5 m's or divide across by 0.5 m to get v squared is equal to g, or v is equal to root g. And we saw before that root g is 3.13 meters per second. Question 4, a girl throws a rugby ball, mass 0.4. So we have an m here that's not just m, 0.4. Straight up into the air from a height of 1 meter. And so let's say it goes from here up into the air. It's going to reach this greatest height. So we have scenario 1 over here and scenario 2 over here. So the greatest height, we know that the speed becomes 0. We're looking for this height. So h is equal to h over from position 1 from down here. You have v7. And its height is 1 meter above the ground, so h is equal to 1. So for position 1, mgh plus a half mv squared becomes m 0.4 g times 1 plus a half times 0.4 times v squared, which is 49. Tidying this up, we're going to get 0.4g plus that's going to be a fifth of 49. It actually goes back to 9.8, and 0.4g plus 9.8 works out to be 13.72. Okay, for scenario 2, we look up here, a half mv squared plus mgh in whatever order you want. So you have a half times 0.4 times 0, so that one will cancel for us, plus 0.4 by g by h is what we're looking for. So 0.4 gh, so 0.4 by g is equal to 3.92, so that's 3.92h. So we have 3.92h is equal to 13.72. So h in this case has to be 3.5, and that's in meters. Similar type of question with number 6, a tennis ball hits straight up in the air. Here's the ground. Here's my tennis ball. My height above ground, 0.5 meters. And it's going to go vertical, straight up in the air, so it's going up this way. Find the greatest height reach, we need this height here. So in scenario 1, from down here, mgh plus a half mv squared is going to be, what other information are we given? We're not given any information. We're given initial speed. We're not given any mass other than the m. So we can use mg by 0.5 plus a half m by that 14 squared, which is 196. So that's a half of 196 is 98. So we have 98 m plus 0.5 mg. So up here, position 2, what do we know? We know velocity is 0 in position 2. We're looking for h. The mass hasn't changed. So we have mgh plus a half mv squared is going to become mgh plus a half m by your 0, where the velocity becomes 0, to be squared. So we just get mgh. So equating these two things, we can just write it here, equals mgh, dividing across by m. We're going to get 98 plus half of gravity, which is 4.9. That's going to be equal to 9.8h. So 102.9 divided by 9.8 has to be equal to h. And that's going to be worked out to be 10.5. Gravity is actually 10.5. And that's in meters, would be equal to h. Part 2, the speed when it hits the ground. So we've got another diagram to draw. So let's draw a diagram. So now we have the tennis ball above the ground. We found the answer to be 10.5 for the max distance above the ground. So now we have scenario 1 up here, where velocity is going to be equal to 0, where height is going to be equal to 10.5. So for scenario 1, mgh plus a half mv squared is going to be m times g times 10.5 plus 0, a half m by the velocity squared is 0. So it's just 10.5 mg. And then here for scenario 2, we've got height is equal to 0 and we're looking for its speed. So in scenario 2, mg by 0 plus a half m by v squared. So we're going to get 10.5 mg has to be equal to 0.5 mv squared divided by m, and dividing across by 0.5, we're going to get 21g is equal to v squared. So v is equal to the square root of 21g, and that works out to be 14.3457, correct to 2dp, 14.35. And that's velocity, and that's in meters per second.